Hello everyone, I am Nemanja Stamenic from BNR. I am a technology evangelist from OPC FX, and before that I was active in TSN standardization at IEEE. So let's start maybe by asking a question. I hear this question surprisingly often. What is time-sensitive networking? Is it a standard? Is it a protocol? Is it a field bus? And the answer is that it is a whole set of standards developed at IEEE 802.1 working group, and also including some amendments to existing standards. And what was the motivation for this is the fact that, as you know, standard Ethernet before TSN doesn't really have the actual conception of time, and this is then of course completely suboptimal for hard real-time use cases. And the idea was to extend standard Ethernet to support also real-time use cases with the hope to achieve, like Rainer mentioned, convergence in IT/OT, maybe build a bigger ecosystem, include real-time features in standard Ethernet chips, and have maybe cheaper chips and so on. So this was the main motivation, and it started with professional audio-video technology. And they have had a situation there where they had a lot of different protocols that were not interoperable with each other, and also different traffic types when you organize these huge concerts and so on. And this sounds familiar to some of you probably, this situation. And this is how it all began. There was a special task group formed at IEEE 802.1, and they did a really huge amount of, and are still doing huge amount of work in standardization. And you can split these standards in many different ways. I chose these 4 clusters. And the first one being synchronization. So obviously for real-time communication you need timing and synchronization features, and this was done in 802.1 AS, which is a profile of 1588 precision time protocol. And there have been then later some amendments to it, mainly driven by industrial automation use cases. So we have hot standby that provides you with increased reliability. You have additional Yang module for configuration of the protocol and so on. Yeah. Then obviously you need traffic scheduling and shaping, which I here call low latency, bounding latency. And the main standards there are credit-based shaper, you have frame preemption, time-aware shaping. Cut-through forwarding is still an ongoing project, and so on. So this is, I believe, the largest chunk of work that has been done in TSN task group. Then you have reliability standards, FRARE, very important one, frame replication elimination, PET control, pair stream filtering, policing, and so on. So basically, this set of tools enables seamless redundancy, which is obviously crucial for many real-time use cases. And then you have also a set of, I would call them guidelines or standards for network management, basically, and resource allocation. And latest one maybe worth mentioning is the QTJ standard, which is kind of an update and extension of the QCC standard. So this standard defines this network management models, the centralized one, distributed one, and so on. Yeah. And also an interface between CUC and CNC. There is a Yang module for that defined in the QTJ. So important one, especially for industrial automation. And so the group, as it usually happens in standardization, representative from many different verticals and markets, and with also different use cases came together, and then wrote a pretty big set of requirements. And I mentioned some similarities between those markets, but there are also some obvious differences. right? So if you compare in-vehicle communication in cars, then you probably don't really care about online network management and so on. You will configure your network once, and then it's in the car set up, and that's it. And then in industrial automation, you will probably or definitely want to have plug and produce. You want to be able to extend your machine by additional module, and it should just work, with automatic network discovery and so on. So definitely some differences there too, and this was then the motivation for TSN profiles. So you can think about it also as a puzzle pieces, and then each market basically chooses the ones that are suitable for its own use cases. And it's not only about the selection of standards, but also parts of standards and some features, and what is optional, what is not optional, and so on. And you also get some sense of the typical network architectures for specific use cases and specific markets, some guidelines and so on. And configuration, of course, too. Guidelines how to configure the networks, and also protocols like you will see later, industrial automation profile, the mandates netconf for conformance class A, and so on. So it all started with audio video, and right now there are 3 profiles in development: industrial automation profile, automotive profile, and aerospace profile. And the one that is most relevant for us is the IEC IEEE 6822 TSN profile for industrial automation. This project started in 2018, and one of the main goals was convergence, right? Also middleware convergence, so that you can use common networking layer and then build and then build the different middlewares on top of it, or use the existing ones. And when you have such requirements, then you will have kind of a complicated situation, because people will not give up some features that already exist easily in other solutions. And this was one of the reasons for this long duration, and maybe something that we should keep in mind when we become nervous for OPC deliveries, because only the profile took 7 years to and it will be published at the end of the year, I hope, most probably. But something that should keep in mind. So when you do such ambitious projects, when you want to really converge different companies, different field buses, different use cases, if you want to really do it in a quality manner, then it takes time, and that's it. There is no other way around it. And so the middleware convergence is one important feature there that you get with 6822 in theory. So you could use the same network to have different middlewares there. OPC being one of them, of course. There are 8 traffic types defined in the profile. So this is also something that we heard in the previous presentation from Rainer, that this is something that customers want. They want traffic convergence. They want to be able to combine maybe really hard real-time cyclic traffic with strict deadlines, with some completely best effort IT traffic and everything in between. They want to combine this in the same network, and this is what you can do with 6822. Then, of course, security was one of the important aspects, but important to note here is that the security is mainly focused on network management. So the network management part is secured, and TLS is mandatory in this case. There is access rules, key store trust roles, models, and so on. So I would say a pretty comprehensive security package for network management. Then the network management itself, it leans a lot on the QDJ standard. It mandates fully centralized configuration model from the QDJ standard. And the netconf also for conformance class A. You have to use Yang, you have to use this netconf database model, and so on. So really, as the title said, common network management approach, very thoroughly defined, I would say. Then obviously bounded latency, so you will get from the network after you request your stream, you will get a transparent answer if this is possible or not, and if it is possible, then you get your latency guaranteed. And I already mentioned the standards in the previously, so I will not repeat, but basically by using different traffic scheduling and shaping tools, preemption and so on, you can achieve this. And the last one, or the first one, timing and synchronization, completely based on DAS, and even the two amendments have been developed as a response to requirements from the profile itself. So you have a hot standby, and you can also configure it with netconf. So where are we now? I mentioned briefly that the effort started in 2018. Now this is a joint project. This I forgot to mention, IEC and IEEE, and the development is hosted still at IEEE. And now we are in the second, in the second recirculation assay ballot. So this is the last stage of the standard development. So technically the standard is completely stable. It's now more of formalities. Yeah. So it will be published at the end of the year. You can access it, you can take a look, you can start playing with it, you can start using it. So we can really say that TSN specification for industrial automation is ready to be used. And this is, I would say, a huge milestone for the community, since it took 7 years to get to this stage. And then there is TIACC, which is industrial collaboration between CLPA, ODVA, OPC, and PI. So all the major players are there. And the goal is this is hosted by Avenue. The work is hosted by Avenue, and the goal there is to come up with a common test plan for 6802. The initial idea was to do it at IEC simultaneously, and to have an IEC standard for the test spec 61822, but this didn't happen at the end. But the TICC still has an ambition to do it after they finish their work, and they have a pretty ambitious plan to have the final version next year. So we will see how this goes. I wish them a lot of luck. This would be then also very important milestone. And then I will conclude with this slide. So Rainer and Peter already mentioned a lot of cool features and value propositions from OPC FX. So it is very secure, open, future-proof middleware. It has standardized data models for many machine types, for many different domains. I think more than 60, 70 machine types and so on. It has PubSub. And when you combine that with TSN, that is very robust, very reliable, has guaranteed latency, and is middleware agnostic, then you get, I would say, very futuristic solution for the next decades. Yeah. So a huge, I see huge synergy between those two, and TSN is of course now part of OPC FX. So really excited to see how it develops in the future. So this was it. Thank you.